Established. Encrypted. We're live. The show you've been asking for. Advice, technology, and community. Linux first, all others second. This is Ask Noah.
Live from Altispeed Technologies, the Ask Noah Show starts right now. This is the show where we came to do all the things on Linux they said couldn't be done and take your questions on how to do the same. The phone lines are open this hour. To be a part of the program, it is a free call, 1-855-450-NOAH. That's 1-855-450-6624, or send an email to live@asknoahshow.com. My name is Noah Chalai. I am your host. Delighted to be here with you as another episode of the Ask Noah Show kicks off this hour. Every year when I go to a Linux Fest, I always make sure to try to ride in the car with a couple of people on the way to the restaurant, on the way back to the studio, whatever it is. One of those people is Allan, Jude, the man who literally wrote the book on ZFS. Allan joins us this hour to talk about ZFS system administration backup. It's going to be a jam-packed episode. So without further ado, Allan, welcome into the program.
Hey, Noah, thanks for having me. It's been a while since I got to chat with you.
So I guess, Allan, let me start with this. How did you get into technology? How did you get into BSD and software development and networking and all of the things that you have become proficient at?
I think the earliest part was when I first got the internet, access to the internet at home was, it was to my birthday present for my 14th birthday. It was dial-up, but for some reason the ISP had to mail you the startup kit that had your username and password in it or whatever. So it took almost 2 weeks for me to get this stupid kit in the mail, and all I needed was the username and password, and I could have done it without, the discs they send you in the mail and so on. But once I knew I was getting the internet, I was talking to my neighbor about it, who was gotten into computers fairly recently, and he had done the MCSE exam or whatever, and kind of transitioned from being a heavy equipment operator into a computer person. And he told me, I have this friend and he runs this IRC chat server out of his basement in Vancouver, and we all hang out there and chat and so on. And so the very first thing I did when I got the internet on my home computer was download an IRC client. Of course, not knowing the address or whatever for the friend of my neighbor, I just clicked on the first server that said Vancouver and got on IRC and started playing around with it and talking to people. And very quickly I got into, okay, so how do I run a server of my own of this? And eventually I found someone that knew how you did that or whatever, and they directed me to the software. So I downloaded this .tar.gz file. I'd never seen one of those before, but it opened in WinRAR, where I had opened all the other archives I've downloaded from the internet. So I was like, okay. And I'm looking through it, and then I asked the guy, there's no .exe file in here. How do you run this? And they're like, oh, you don't run it on Windows, silly. You need a shell account. I'm like, what's that? And so eventually I learned a bit about that and got my first shell account, which I think at that time, because I was so young, I didn't have a credit card, involved mailing a money order to this guy once a month that I'd have to go and buy at the post office. And it was like my entire allowance or whatever. But I got access to a shell on basically a telnet login on this guy's FreeBSD server in Quebec. And from there, I could compile software by hand with, /configure, answer a bunch of silly questions, and then make and compile it all and run it and, leave a process running in the background while you're logged out. And I had this IRC server now that, I could be in charge of.
So at this time, Allan, there are obviously you could have presumably installed a Linux or Unix-based operating system and run it that way. At the time, I'm assuming that those operating systems weren't as popular, and so people that wanted to use that particular operating system for one particular purpose would just pay a monthly or yearly fee or whatever and get access to somebody else's computer that ran that operating system. Is that how that worked?
There were a couple of reasons to use the shell account instead of my own computer. I only had one computer, and if you're brand new to it, I wasn't going to switch the operating system on my computer and lose my ability to play all my games and so on. The other main thing was, I had 33.6K, or no, maybe then it was still 14.4 dial-up. No, it would have been 33.6 by then. I only had dial-up, so I wasn't online 24/7, whereas I wanted the IRC server to be online 24/7. So running it on somebody's server who had a T1 line instead of my dial-up was the main reason why I was paying this guy $10 a month to be able to telnet into his machine and run my process on his computer instead of on my own.
So you get the shell account, you get your IRC server set up. Did anybody join? Did it become successful?
Not especially in the beginning. Later, somebody actually ported the software so it could run on Windows, and I did that as well. And then, networked a couple of servers together. And that's really where I started to learn stuff. I started learning about like the protocols that programs speak. So actually learning to connect to IRC with like Telnet and do all the things the client does and actually, respond to the messages and so on. And, learned how to send an email by hand using, Telnet or whatever, or Netcat, and even like make an HTTP request by hand, and started learning a lot about protocols and stuff. And so that got me interested in programming a bit, but also, so in IRC, there's actually two different protocols. There's the protocol that your client speaks to the server, but there's a slightly different protocol that the servers use to talk to each other. And, there's a lot less, well, I wouldn't say less validation, but when you're connected as a server, you can do things that normal people aren't allowed to do. And so I quickly evolved from scripting little bots in the MIRC scripting language that reacted to things you said in the chat room to writing a bot that connected as a server and had unlimited power. And could basically do, it could change other people's names on them and stuff because it had what was called a U-line.
And so you're essentially just set out to troll people.
A little bit. But they're mostly people I knew. Like, you had to get people to connect to your IRC server, and if you just trolled them, they weren't going to stick around. That led into more programming and wanting to learn more about programming. But also, it led to, look, all the programming I've done has been around networking. Like, it's all client-server stuff and speaking protocols and stuff, and not just, I'm not really building apps so much as I'm building network stuff. And so that, and then during high school, I did a work term at the power plant in the IT department. Mm-hmm. And the combination of those two things made me decide to go to college for network engineering and security analysis instead of software development. Because all the programming I learned, I taught myself. And, programming is something you can do with one laptop. But if you want to learn serious networking and like running Windows and Linux and BSD servers, it really helps if you have a room with 40 computers in it and a bunch of routers and all the cables you could need to make something out of it.
So you get to college, you sign up for these programs. Did they deliver on what you expected it to be when you got there? Was it the kind of exploration of technology that you were hoping for?
So it was what it said on the tin. And, part of the reason why I went to this specific school I went to is because it was almost all time spent in a lab actually doing something on a computer, not, reading textbooks and having theory classes and so on. Of course, by the time I got there, I was past a lot of it, although it did fill in some of the, bits that I had kind of glossed over. When you're learning yourself, you can end up with these blind spots, things you didn't know that you didn't know, and that, filling those in could help you understand stuff better. And then I had also never, outside of the little bit of work I did at the power plant, which back then was Windows NT 4, in college it was useful to learn about the Windows Server stuff, just so I knew the basics of it. And, in the end, anybody who can admin Unix usually can understand Windows better than somebody who only knows Windows.
Let me ask you this, Allan. When you, at some point, as you're exploring technology, you come across and kind of settle on the BSDs and that part of the Unix world. Later down the road, ZFS comes along. Tell me the story about how you learned about ZFS and started to become interested in it.
First hearing about ZFS, I think it was actually my very first conference that I went to, which was BSDCan 2012. And I think one of the morning presentations was from Justin Gibbs, who is the president of the FreeBSD Foundation, and Will Andrews, who's now a friend of mine. And they had been working on a set of changes to ZFS to make it faster when you were updating only part of a block, not a whole block. It's interesting because that code's actually about to finally become integrated into ZFS many years later. But it's a long story. But so they were talking about this, and they did just a brief glossing over of what ZFS was. And I was like, whoa, that sounds really cool. How come I'm not using this? So I started digging into it. And it just so happened that a couple of months later, for Scale Engine, we were building our first real storage server. Before it was like one of our servers had a couple extra hard drives in it, and we, put the customer data on it. But we were getting to the point where we needed to store tens of terabytes of video in a way that made sense. And so we ended up using ZFS, and I started learning about it. So by the time we came to a year later, for basically exactly a year from when I first learned of ZFS, going to the next BSD CAN, on the train there, I started rewriting the FreeBSD handbook chapter on ZFS because it was very basic, and it started with the complicated stuff of if you're using a 32-bit computer, you need to recompile your kernel with all these settings and blah, blah, blah. It's yeah, but most people aren't. So don't put the scary stuff in appendix at the end for people that are doing something weird, like trying to use it on a 32-bit computer. How about actually explain what it is and why it's useful and convince people to try it rather than scare them away with, you need a custom kernel with these weird settings. And so I started writing some documentation on it and went to, we have these things at BSD CAN called doc sprints, where some of the people that work on documentation are sitting in a room each evening, and anybody who wants to help on documentation can show up and actually get, one-on-one help to push this forward. And so I did that. And then by the time I came back to BSD CAN again in 2014, that's when I was given committer access to FreeBSD as a documentation committer. And then it just kind of went out of control from there.
I want to dig into ZFS a little further. So how would you describe ZFS to a person that has never heard of it before and maybe doesn't have a lot of experience with various file systems? Maybe they've heard the name, maybe they've heard it tangentially referenced, they've probably certainly heard of RAID, but they don't really know what makes ZFS. How would you explain that?
To start at the beginning for that, you think of how we normally use computer or disks in a computer. So normally, like in your desktop, you probably have one hard drive and then you put a file system on that and use it. But when you needed more space than that or you needed redundancy, then we started having this concept of RAID, where you could take multiple disks and put your file system on it. But it turns out almost no file system actually supports using more than one disk. So we basically created RAID, which would take a whole bunch of disks and create one what we call logical disk. So it makes a virtual disk that looks like one big disk to the file system that you're going to put on it, but is actually made up of a bunch of separate disks, either striped together or mirrored or using something like RAID 5 or 6 where there's parity and so on. But a lot of what exists with RAID is all about just tricking the dumb file system into thinking there's only one disk, and then doing all the magic under the hood of dealing with the fact that it's more than one disk. The problem with this is the file system doesn't know that there are multiple disks, because most file systems can't handle that. So you end up with a volume manager, which is your RAID or MD or LVM or whatever you're using on Linux, and then on top of that you have your file system like XFS or ext4 or whatever. What ZFS does is combine those two concepts together for a couple different reasons. So it's basically the volume manager and the file system, but they talk to each other and the file system actually understands. So for really important parts of the file system, like the metadata that's critical to being able to read any part of the file system, ZFS will actually store 2 or 3 copies of some of those blocks. And because it knows the layout of your physical disks, it will make sure that copies of those blocks go on different physical disks, so that if one disk dies, there's still copies on other disks. Whereas a regular file system doesn't have the option to do that because it doesn't know about the different physical disks. But the main thing that made ZFS better is, especially if you're thinking back before we had things like LVM, where you could dynamically resize partitions. If you think back to Linux in the early 2000s, when you first installed Linux, you had to divide your disk up. And I need this much for my home directories, and I'll have this much for the operating system, and so on, right? And then you'd always end up with, I made my /var too small, and now I have to move some of the log files over here and make a symlink or something. So ZFS takes the idea of taking all your space in one big pool and then thin provisioning file systems out of it. So each file system can take space from that pool whenever you need it for writing new files, but when you delete stuff, it gives that space back to the pool so some other file system can use it. Whereas with a regular, partitioned hard drive, once you partition it, it's really hard to resize those.
What makes ZFS better at its job of layering and combining multiple drives? What is wrong with the traditional method of combining a bunch of drives with the hardware layer and layering a virtual volume manager on top and then putting a file system on top of that? Is there an advantage in ZFS being aware of all the parts? Does that translate to either performance or reliability for the end user standpoint?
Yeah, it can definitely translate to better performance. It also improves the error handling a bit. And allows ZFS to make decisions when it's laying out data and files to make sure that it's taking best advantage of your hardware. But yeah, one of the big things that ZFS does that most other file systems don't is end-to-end data integrity. So when you're writing data to ZFS, in the metadata, which is actually stored in a different place than the actual content of your file, it also has the checksum of the file. By default, that's a Fletcher 4 checksum, but you can also use like SHA-256 or whatever. And then every time you read data back from the disk, ZFS will calculate that checksum and compare it. And if it's not right, it can use the fact that it knows about other disks to attempt to read the parity or a different copy if it's a mirror or whatever, to find the version of the data that's correct. If you have a regular hardware RAID of, say, mirrors, if one of the two sides of the mirror is wrong, the RAID array has no way of knowing which one is the right one. Whereas because ZFS has these checksums, it can know which one's right, and then it'll overwrite the wrong one with the correct data. Whereas with hardware RAID, it was like, it doesn't know that the data is wrong, so it just gives you the wrong data and you don't know. And B, even if it did, it wouldn't know which of the two copies is actually the right one, or if neither of them are right. Whereas ZFS, because it has the checksums, can tell which is the right data, and it makes a guarantee to you that it will never give your application the wrong data. If all the copies are wrong, because which can happen for lots of reasons. You have bit rot on hard drives where a bit just gets flipped for some reason, or if you have a bad cable, or if bad memory, or who knows, lots of different reasons that can happen. ZFS, if the checksums don't match and it can't find any other copies, it will return an error to your application saying that data is not available, rather than giving it the wrong data, which for some applications can make a very big difference, especially like scientific applications where there's a lot of data, and if any of it's wrong, it could make the whole experiment turn out wrong.
Obviously, ZFS is probably the preferential file system for a server. I think you've made that case very well. Are there any reasons why somebody might want to run it on their desktop or on their laptop, on their daily driver computer?
Yeah, that's a question I get a lot because, a lot of the features of ZFS are all about, well, you have multiple disks so that if one fails, you can deal with it. It's like my laptop only has room for one disk, or maybe two if you have a bigger laptop or whatever. But there are still many advantages to it. The first one is we talked about the being able to have many different file systems that are pulling from the one pool of space. You can the other thing that ZFS does, I guess, that we should talk about is ZFS is what's called copy on write. So when you change a file, instead of overwriting that file in place, ZFS writes the changes to a different place on the disk, and then after a couple seconds, if you're not using it, if you didn't keep the old copy, that'll become free space and something else can be written there later. But the advantage to this is you can do what are called snapshots. So you make a snapshot of your file system at any time, and it takes basically 0 seconds to make the snapshot. And unlike a snapshot in stuff like LVM, the number of snapshots you have never impacts the performance of reading and writing from the disk. It only impacts the performance of getting a list of the snapshots. So if you have thousands of snapshots, that might take a couple seconds to make the list, but the actual reading and writing to your drive will never be any slower, whether you have 0 snapshots or 1,000 snapshots. With those snapshots, basically what you're doing is when you have that copy on write, when you write the new copy, if the snapshot's still using it, it just won't erase the old copy, and now you'll be able to have either copy. The other thing this lets you do is what's called a clone, where you can actually say, I have my home directory right now, or maybe a better example, I have, our website, and we're about to upgrade the version of WordPress or whatever we're using on our website. So first we take a snapshot of it, and then we clone that over into a development environment, and then we try the upgrade, and we can see if it worked. And the main advantage of a clone is the blocks are shared. So when you first create a clone, it takes 0 extra space. It's just an exact copy of the original file system, but you can change it, and it only takes up the space of the blocks you actually add or overwrite. And then later, you can either decide to keep only the clone or only the original, or both, but any blocks that remain the same between them don't take up extra space. So the main reason to use ZFS on your laptop is that you can do this for your root file system with what ZFS calls boot environments. This will ship as a default feature available in Ubuntu 20.04, which comes out any day now, with their ZFS on Linux support, and it's been in FreeBSD for years now. So what that means is I have my laptop here that, if it wasn't for what's going on in the world right now, I'd be going to a conference to present very soon. In previous years, it would have been crazy to consider upgrading the OS on my laptop the day before I'm going to a conference where I need to present off that laptop. But with boot environments, I can basically clone my working system and upgrade the clone while keeping the original working version. So I can upgrade, and if something doesn't work, I just reboot from the boot menu, just select the older snapshot and boot that up, and I have my laptop what it looked like last week instead of what I did to it last night. And it allows you to basically have no worry about upgrades or any, operation you're going to do to your computer. You can always go back to this known good state. But because ZFS is sharing blocks, it's not going to take up as much space as having, 2 entire installs of the OS on your laptop or something.
The snapshots do occupy space, though, right? Let's say you have a 150 gigabyte file, and that file is no longer needed, so you delete that file. But that file is part of maybe an older snapshot. We don't necessarily get that space back, right?
Right. So when you create a snapshot, at the instant you create it, it doesn't take any extra space. But then any blocks you change or overwrite or delete, you won't get the space back until you delete the snapshot. And there's a ZFS command you can do to see how much space you would get back so that you can know, if I get rid of this snapshot from, 4 weeks ago, I'll get back 25 gigabytes of space on my laptop. And if I need the space, then I can do that.
How long do you recommend people keep snapshots? Obviously, that's going to depend on the situation, the environment, the amount of data stored, the amount of available capacity, all of those things. But everything being equal, if you just had your run-of-the-mill mom and pop business, they have 10 to 15 employees. Let's say they have 20 terabytes of a file server. How long would you keep the snapshots in place before you have them automatically expire?
That can depend on a couple things. I think the first thing to look at there is, what's the worst case, how long it could be before you found out that something was screwy? That's a problem people often have with backups. It's like, we take a backup every week and then we get rid of the old backups. It's like, but what if we didn't find out, or, people that don't have real backups, they just have like an rsync copy to an external drive or something. What if you don't find out that you munged up that Excel sheet until a week later? And so now all your extra copies of it are also the broken version. So the biggest thing is, how far back in time might you need to reach to get the not broken version of a file? In general, at least a month probably. But again, if you're running out of space, you have to prune some. And if you're not running out of space, you might decide to keep longer.
Why are snapshots not a backup?
Because they're on the same hard drive. So if that hard drive fails, then your main copy and your backup are gone, right? Now, ZFS, you can use snapshots to make backups. One of the big advantages of a snapshot is it never changes. So if you make a snapshot and then mount it somewhere and then make your backup from that, you know that all the files aren't going to change while you're backing them up, right? The biggest problem with trying to back up, say, a database server is that somebody might change something in the database while you're backing it up. And normally that requires like locking the database tables and doing all this. But with a snapshot, you can back up, take a snapshot of the computer, let the computer resume what it was doing, and then back up that snapshot. And the other thing is ZFS has a protocol for this, for ZFS replication. It allows you to actually take a snapshot and turn it into a stream you can send over the network. So you can do like ZFS Send and then the name of a snapshot and pipe that into, SSH or something and copy it off to another computer where you could just stick it in a file, but generally what you do is actually pipe that into the ZFS receive command, and it will recreate that file system and snapshot exactly how they were on the sending machine on the receiving machine. So you can basically, if you have an office with 10 or 15 employees or something, you can have a backup site somewhere where you have an exact copy of all your files with your snapshots that's updated frequently. So like at my video streaming company, we do this for customers upload videos to us. And also we have recordings of their live video streams. We snapshot those data sets every 15 minutes and replicate all of that to our offsite backup location, which is about 60 miles away. So that if something ever did happen to our file server, like if the building burned down or who knows what, we could always run off that backup or drive to that backup, pick it up, and take it to a data center.
What do you recommend the best core? Like, obviously, if they have ZFS, ZFS Send is a great way to go. By the way, I should ask, is ZFS Send as simple to set up as just ZFS Send on one side and ZFS Receive on the other side, or is there a little bit more lacquer that has to be put up to facilitate that to actually work?
That will actually work, although, you're probably going to want to automate it, and that's where you get a little bit more lacquer, where you're going to have to. So when you do incremental replication, where instead of sending all of your, if you have 20 terabytes of data, you don't want to send it all every night. You want to send only the changes, which is something ZFS is very good at. Unlike a tool like rsync or Borg or SyncThing that has to look at every file and see if it has changed, ZFS knows from the file system, every block that's changed between this date and this date, it can collect that really quickly and start sending it a lot faster than something like rsync or Borg and so on. But when you're doing incremental, you have to know from the backup side. So the ZFS replication protocol is unidirectional. It just goes from the send side to the receive side. There's no two-way communication. This is because one of the other options you could do is use ZFS Send and write it to a tape and not run ZFS Receive on that until 5 years later. And so it doesn't have any real-time communications. So the send side needs to know what's the most recent snapshot that the receiving side has as the starting point for, send me the differences between that and, what the current snapshot is. So some kind of script or tool really makes that a lot easier rather than having to do it manually, which is not what you're going to want to do if it's a backup because you want that automated. There are a couple of tools. Jim Salter has one called Syncoid, and my friend Christian wrote one called ZRepl that are good. And technically, I'm the maintainer of one called ZXfer, but I don't recommend it. It's a lot more simplistic than the other two. The send receive protocol has support for what's called a raw send. So you can, if it's encrypted on the source machine, you can send it to a destination machine that never has the key. So you could theoretically back it up to somebody else's NAS, and they'll never be able to read it unless you go over to their machine and type, ZFS load key and put in the password.
What do you recommend for most people to back up? And this is everything from, if they have ZFS, obviously they could use something like ZFS Send, but let's say it's just a regular old Ubuntu 1804 install, maybe it's even a Windows box. What are some of the go-to backup strategies that you would suggest for a person that says, I know I need to back up my data. I want to have copies in multiple places, but I don't know where to begin. I don't know what tools to use. I don't know how many copies to store. I don't know where to store them.
Yeah, that's a complicated question because the answer can be a lot different depending on different things. For like an office type thing where there's going to be at least 5 or more computers you want to do, something like Bacula works very nicely, but it's probably a little too much setup if it's like, I have my desktop and my laptop and I just want to back up my personal stuff, then it's probably a lot of overkill and extra setup to do something like Bacula for that. For my important personal files, like my tax return stuff and my business files, I use Tarsnap because I trust the encryption it uses and the way it's set up. But I wouldn't recommend it for, backing up large collections of family photos or something because, the price is not great for backing up terabytes of data.
You said you trust the encryption, and obviously the encryption is going to come down to a certain amount of how strong your passphrase is. What do you recommend for people that are going to be using online cloud-style storage, even to include Tarsnap? What do you recommend, what security precautions do you recommend that they follow in order to safely store their information on the cloud?
So the very first one that Tarsnap does right is the encryption happens on my computer, not on theirs. And they never know the password. This has a downside, though. Because all the encryption happens on my machine and they never have the key, they can't reset the key, the passphrase, if I lose it. Now, that is slightly a disadvantage, but it's also how you can tell how secure this online service is. If they can reset your password or rescue your data for you, that means they have access to your data, which maybe that's fine with you. Maybe you need the ability for someone to reset the password if things go haywire. But if you're a little more on the, not paranoid, but if you're more concerned about the security, any service that has the ability to reset your password or something like that for you means that the encryption isn't actually, that they're maybe encrypting it to your key and their key so they can always rescue your stuff for you. But if your biggest concern is that no one else has access to the data, then you need to make sure that they won't ever be able to unlock it for you because it means they would have access to it.
I have to ask, Allan, I have done all of my backups thus far in my life on my own hardware because I figure I own an IT company and we set up backup solutions for other people. Why wouldn't I manage it myself? And so to hear you say that you're trusting a lot of your data on Tarsnap, I guess I have to ask, what is it in your mind that makes the decision that says, I'm going to go with this service? What is it that they're offering that you don't want to maintain yourself, or what concerns do you have about maintaining local backups yourself?
Right. So I maintain most of my local backups myself. I have basically about 1 gigabyte of data that, I'm extra concerned about. And I send that off to Tarsnap and it costs me like 25 cents a month. So I don't ever have to think about it. But, for the 700 terabytes of data we have to back up, I do that myself, exactly like you were saying. It's just for the really important things like my taxes, the general rules of backups is A, if there aren't 3 copies of it, it doesn't actually exist. And B, if you haven't tested your backup, you don't have a backup.
How do you recommend people test their backup?
That can be as easy as, restoring into a VM and making sure that you can do that, or even just picking a couple of files out of your backup and making sure you can restore them. Because nothing worse than resting easy knowing that you have these backups, and then when something does blow up, you go to get it and it's like, oh, it turns out it was not backing up any files that were bigger than this, or, that it was not able to read this file because the program was open at the time, or whatever it might have been.
We had a client, this is literally probably 4 weeks ago, had a client that called us in a panic and said, we need you to come in and evaluate our backup solution because it's failed miserably. I said, okay. So we came in to look at what they had doing for backups. And it turns out what they had done was they had created shortcuts from the files into a file server, and then we're backing up the file server. So, of course, when they went to restore all of the quote-unquote data, all they had was a bunch of shortcuts. None of the actual data had ever been backed up, and it had been that way for years, just nobody had ever noticed, because when they clicked on the shortcuts, it opened the file, so they just assumed.
It opened fine.
But they didn't test, like you said. You said that there are 3...
Or even, they thought they were testing, and it wasn't necessarily.
Right. A true test would have been to take it into a completely separate machine and try and restore the data and see how that comes out. You said that people should have 3 backups in order for the data to exist. So that seems like the bare minimum. Is there do you have a recommendation for 3 is the absolute minimum? Obviously, the more the better, but here's where I try to stay.
Generally, I have the main copy on my computer, and then just 2 backups is probably enough. You don't want to be spending all your time or money on extra space to back things up. But oftentimes it also comes down to it's cheaper to buy more space than to decide what you don't need to back up and then regret it.
That's wise. So let's talk about that for a second. What role? You said that tape plays a role in the ZFS Send command in that you can back data up using ZFS Send to tape, and then you can retrieve that data using the ZFS Receive command much later. My question to you is, what role does tape play in today? Is it still a viable storage option, and for what kind of people and for what kind of data?
It's still somewhat usable. I personally don't use it. We have, a huge amount of data, and we just didn't make sense to invest in the tape hardware for that. And the other thing is we need our backup to also be usable as a hot failover. We think that our current storage server has enough redundancy that in almost all cases it would keep working. But if it didn't, if it's offline, there's a greater chance that, that whole building is offline or something, and we need to be able to do a DNS failover and run the entire company out of my basement instead of out of the data center.
Okay, we can't just hold on. We can't just drive by that. Talk about this DNS failover. How does that work?
So we use a service called DNS Made Easy, and basically just like regular DNS, you have all the regular zone types, but they have basically what's a dynamic A record, and basically they monitor multiple different IP addresses, and the first one that is up is what that resolves to. So if our primary web server is ever down, they detect that within 60 seconds, and it updates our DNS records to point to the IP of our secondary web server. And our website gets served out of the second data center instead of the first one because it's not responding to the checks that they're doing. And if that one's down too, then it falls over to my basement.
What role do Blu-ray discs and optical media play? I understand that, especially with flash-based media like SD cards, flash drives, even SSDs to a lesser extent, if they're unpowered for long periods of time, that can cause problems. And so the next best thing up is a regular hard drive, but even they, because they're mechanical devices, are prone to failure, so on and so forth. And so the people that are archiving data for long periods of time, hundreds of years, if they want to try to pass that data down maybe to the next generation, something they want to make absolutely sure that they never, ever lose. Have you dealt with anything like that in the past? Have you thought about using optical media for maybe those, that you say you have 1 gigabyte of very important data that resides on Tarsnap? Have you ever thought about backing something like that up to optical media?
Not especially, although part of that is my experience with especially like consumer recordable media like that.
Sure.
Is that they don't tend to last that long. Like, when we all got our first burnable CDs and DVDs, we were told they would last 100 years, but I have a whole stack of them over here that are not very readable now, and it's only been 15 years since I wrote them. But I do know like Facebook is using very large libraries of Blu-ray discs to store a lot of the photos people have, and then just have hotter caches in front of it, because there's a very high likelihood that when you post baby photos that 3 years later nobody's going to be looking at those, but Facebook does want that when you click on it they have to be able to go and grab that disk and show it to you, but they don't necessarily need it hot online on an SSD so that thousands of people could look at it at once, like they need the pictures attached to brand new posts.
That's interesting. So I wonder how that works from a practical perspective. I go on my I go on my Facebook page, I scroll way back to 20, whatever, and I click on a baby photo. Am I just left with a spinning thing while some sort of mechanical robot loads a disc into a player and spools up and then copies it over and all of that?
Kind of. I think they have some videos online of they look like those giant tape libraries, but they do it with the Blu-ray discs, and they have a lot of them in basically rack-sized mechanical robots. In general, they're not that slow. They can only read so many at once, but as long as not everybody is scrolling back 10 years on Facebook at once, it's probably okay. And I think there's some level of like prefetching that can happen too. As you're scrolling down more and more, it can be like, oh, I'm going, and it might also be grouping things. So, when you pull up all of your stuff from 10 years ago, they're probably all on the same disk. And so once you load one of them, all of them are hot.
Gotcha. Aside
I don't know all the details of how that one works, but it was interesting to see the giant robots and that they were actually making use of Blu-ray.
Yeah, it kind of reminds me of the Hackers movie where they're fighting over the VHS tape that is going to play for the cable channel, and Zero Cool and I forget who, Asa Byrne are sitting there fighting with these remote robots, so which tape was going to get inserted into the thing and play over the cable network. It's like the modern day equivalent of that. What configuration, Allan, do you recommend for people that are setting up ZFS storage? They are listening to this episode and they're saying to themselves, this all sounds great. I totally want to do this. Sans the Blu-ray robot. And so they're sitting down. What storage recommendation, recommendation, how many drives, for example? Are there any particular drives that you say use these, don't use these? Any particular place that you'd recommend people buy servers from? And then how do they go about actually setting that up? What kind of RAID Z level would you suggest that they use?
That one can depend a lot on what you're going to do with it. So if you're building like a home media server or something, even though it's slightly more expensive, I do recommend doing basically RAID 10 sets of mirrors because it gives you a lot more flexibility. So like even when I set up a big NAS for other people, I often do it this way because, say you have 6 hard drives to start. If you did that as one, RAID Z2 of the 6 drives, you would get 4 drives worth of the capacity. But when you wanted to add more space, you'd have to buy 6 more drives. And, even now, 6 hard drives at once is kind of a big expense. For some people, that's fine. Like, for my video storage company, we generally buy 12 different 12 terabyte drives at once to grow our pool. But, for some people, that's obviously not practical. So with mirrors, if instead you took those 6 drives and did 3 sets of 2, you would get a little bit less space, right? You only have 3 hard drives worth of space instead of 4 out of the 6 drives. Later on, if you wanted to add more drives, you could add just 2 more drives at a time. So then you're at 8, and maybe that's the limit of how many can fit in the machine you have. So then what you can do is replace 2 of the smallest drives with 2 bigger drives. And again, only having to buy 2 drives at a time, you can then, start with all 2 terabyte drives, and then later on replace some of the 2s with 4s, and then next time you replace another set of 2s with 8s or whatever is the most price efficient at the time. And it allows you just that much more flexibility to grow the pool in smaller increments that are more affordable rather than having to buy bigger chunks at a time. But if your storage needs are much larger, then doing something like an 8 or 10 or 12 wide RAID Z2 gives you a lot higher efficiency, right? If you're getting the space of 10 out of the 12 drives instead of 5 or 6 out of the 12, then you're fitting a lot more space in the same amount of money. So in general, I would avoid RAID Z1 because having only a single drive for redundancy is probably not enough now, especially when you're talking, if you're building an array that's going to be more than 10 terabytes or something, it gets to take, losing one of those drives, and by the time you get around to replacing it, it gets shipped to you and you install it and it does the resilvering and so on. It could take a while. And then you asked about hardware?
Yeah. Do you have a recommendation how about a recommendation for server hardware? Where can people buy servers that make good FreeNAS servers? I know one of the things that we run into in the field all the time is people will come to us with Dell R710s, R720s and say, can I use this as a FreeNAS server? And we have to tell them, well, you can, but you have 2 options. Well, option 1 is to create individual RAID zeros for all of the drives and just kind of ignore that little header information on the drive itself. Or you can actually reflash the PERT card to have just kind of a bypass dummy card that just presents the raw drives to FreeNAS. But in doing neither of those things, you're setting yourself up for failure if you try to use hardware RAID and then install FreeNAS on top of that. So I guess I'll start with asking, why is that, Allan? And then aside from that, do you have a recommendation of a good server to buy for FreeNAS or ZFS?
So the reason why mixing hardware RAID and ZFS doesn't work out so well is, remember, the point of ZFS is it knows each of those physical hard drives and it can tell, which one had an error and why. If you have hardware RAID, you're giving ZFS one big fake hard drive. And so ZFS doesn't have a place to put like any redundancy. So you're not actually taking advantage of ZFS's version of RAID. And there's one especially big difference in ZFS's version of RAID over hardware RAID. So in hardware RAID 5, you have, your X number of disks and X and Y number of parity disks. And when you write data, it writes to the hard drive, and then separately, it then recalculates the parity of that row and writes that to the parity drive. If the power goes out or something, or the system crashes or whatever happens in between that, it could have updated the data but not the parity. So now when a drive fails and it uses that parity and the remaining data to try to recalculate what was on the missing drive, it'll be wrong because the parity didn't get updated correctly. In ZFS, because we have those checksums, it can realize when that happens and fix it. And also, it writes the entire row as one unit, atomic operation. And because it's copy on write, that means either that write happened or it didn't happen, which means, I guess I should have explained this at the beginning when we were talking about copy on write. But the main advantage to that is, say you're editing an Excel or a spreadsheet on your computer, and you're making a change and you hit save as the power goes out. In a regular overwriting file system, that save was, say, halfway done updating the file. In your regular file system, when you boot your computer back up, the first half of that file will be the new version and the second half will be the old version, which for a lot of more advanced file formats is just going to be an unusable file. And your file system might even truncate the file or whatever. In ZFS, because that write didn't finish all the way, it ignores it and uses the original copy, right? That's why it writes the changes to a different place on the disk, and then once that's done, updates the pointer to point to that, so that if the system does crash or power goes out or whatever, when it comes back up, you have the unmodified version of the file from before, which is obviously better than having a broken version of the file and nothing from before.
Absolutely. This is fantastic. Yeah. I assume that the same reason of why it's a bad idea to use hardware RAID and try and put ZFS on top of that is probably also the same reason of why we don't want to virtualize ZFS without special consideration being given, because by default, ZFS is going to expect to be able to talk to those disks directly.
Yeah. The other main thing is a lot of hypervisors will cheat with the flush command. So one of the things ZFS depends on is after it writes data to the disk, again, we're getting to that copy on write thing, we've written to the new location, and then ZFS issues a flush saying to the hard drive, make all the data I've given you to write, don't tell me it's done until all of that's actually on the media and it will survive a power failure, right? It's not just in the cache on the drive waiting for its turn to get written to the disk. And only once that's done does it do the write that updates the pointer saying, the current version of that spreadsheet is now at the new location instead of the old one. But a lot of hypervisors will cheat at that flush command because otherwise the virtual disks are very slow. And so if the hypervisor lies and says, oh yeah, that data is definitely safe on disk, when it hasn't actually flushed through to the layer below in the hypervisor that's actually talking to the storage media, which, depending on your hypervisor, could be a completely separate machine across the network, then it could mean that, it lied to ZFS, and ZFS's guarantee to you is based on the hard drive not lying. And if the hard drive is virtual and it lies, then you can end up without having that consistent data that you were hoping for.
Let's talk about hard drives for a second. One of the features that intrigues me is encryption for FreeNAS. And the thing that always kind of makes me scratch my head just a little bit is, on one hand, I do understand that, if you're going to discard the disks, if they're encrypted, then the data is as good as useless, and so you can repurpose the disk for something else, or you can sell them or do whatever. Truth is, I've yet to work
or if you have to, send it back for a warranty replacement or whatever.
Right. The truth is, any of the organizations that I've worked with that take security that seriously, that they're really paying attention to what is being stored on their disks and where those disks are winding up, they never repurpose disks. They are destroyed anytime they are taken out of service. Aside from that scenario in which I could potentially reuse a disk, or as you say, return it to a manufacturer for warranty purposes, those sorts of things, is there any particular advantage to encrypting a NAS, being that in order for the encrypted pool to be accessible, the key must be loaded into memory? So if an attacker, ever got possession of the machine, the encryption really isn't doing much for it because they could, do a cold boot attack, dump the key out of memory, and decrypt the data.
Yeah, right. Or if they got their access via SSH somehow, then all the data is encrypted, and they just walk around the file system and do whatever they want. So yeah, none of my NASs are encrypted for basically exactly that reason. There's a much higher chance of me forgetting the password and not being able to access my data than it ever saving me from someone else accessing the data. Now, there is an interesting feature in ZFS that's very new that's coming.
Okay.
So I guess it'll be in the Ubuntu release that comes out this week, and it should be. I think it's in the FreeNAS nightlies, but not in the releases yet. And that is per file system encryption in ZFS. So up until now with FreeNAS and FreeBSD, we did whole drive encryption with Geli, which is kind of like dmcrypt or Lux on Linux. But with this ZFS one, it can actually help you. So each different file system that you have with ZFS can be encrypted with a different key. And if, for example, you're not using it, you can actually unmount it and run the unload key command. And now the key isn't in memory. And no one can access that file system until someone that knows the password comes back and mounts it again.
Wow.
But the other nice thing with that one is the way they stored it, they split the checksum field, which is 256 bits in ZFS, in half. So they have half of the checksum of the actual encrypted data that goes on the disk, and the second half is the MAC, or message authentication code, of the encrypted version. This means that it can still do a scrub or a resilver. So it can, things like replacing a failed disk don't require the encryption key to be loaded, because it can use the checksum to verify the encrypted version, and as long as it's reconstructed that right, someone else will be able to decrypt it later. It means that suddenly your storage administrator doesn't need to have access to those encryption keys. So we do something kind of similar at my business, where all of the credit card information for our customers is encrypted with a key that's on a couple of USB sticks, and I only load that on my computer once a month when I do the billing cycle. Outside of that, there's no way to access the encrypted credit cards in our database unless I've plugged in that little USB key with the decryption stuff on it. And I only do that once a month. And so with this newer ZFS encryption, you'll be able to do kind of the same thing. So I have an article explaining this in more detail coming out in the FreeBSD journal, which is free now. And it goes into detail on how this new encryption feature works and why you might want to use it, and why it gives you a lot more flexibility than the regular kind of whole disk encryption option that has been the only option up until now.
I'm very excited to take a look at this. This is something I plan on implementing as soon as it's available. So this is fantastic. Now, I can't just drive over the fact that you said that your basement is the backup data center for Scale Engine. You have to tell me about this, Allan. What kind of internet, what kind of hardware do you have running in your basement that it can function as a failover for your video streaming company?
From the ISP, we have a point-to-point link. So basically, I have a 1 gigabit LAN that goes from my house the 60 miles or so to the data center. And so one of the switch ports at the data center looks like it's a cable running directly to my house at 1 gigabit. It's actually not. It's MPLS and switches and stuff in the middle, but it's, as far as it looks to me, it's a transparent VLAN that goes from the data center all the way to my house. And it costs more than my mortgage does every month, so it's not something I recommend people do. And then there's a rack in the basement bedroom of my house has been repurposed into a server room and has its own separate air conditioning and everything. It was interesting to get the right kind of air conditioner that could continue to cool the room even when it's below freezing outside. A typical home air conditioner compressor doesn't want to run when it's negative some number of degrees Celsius outside.
Sure.
In the Canadian winter. But the server room still gets hot even when it's snowing out. And then, so we have a rack there, and we have a whole bunch of, basically our typical storage servers, which are super micro machines with dual Xeons and, 128 gigs of RAM. Like the one of them is 24 6 terabyte drives with an expansion shelf that has 44 12 terabyte drives. And then another one is 44 5 terabyte drives. And then we have two other machines that are each 12 4 terabyte drives and so on. So there's like I think 700 and something terabytes of storage in my basement.
How often do you check on your disks?
Quite often. We have our Nagios monitoring will alert as soon as it sees any disk with like smart relocated sector counts going up, or if ZFS ever sees checksum errors on a disk or a disk disconnecting, then we get alerts on that. We do a ZFS scrub only about once every 3 months, even though the recommendation is once a month, but we have very large pools, so we generally only do it once every 3 months.
How long before you swap a disk out? Is there ever a time when you say, yep, that disk has been in, even though there's no problems, even though there are no errors, that disk is in production long enough that it's coming out because I'm not waiting for it to fail? Or do you say, this is why I have 3 copies of my data. I could care less if it fails. I'll just copy the data back over.
So I definitely would want to depend on backups for this stuff because we need it to be online all the time. We do generally have RAID Z 2 or more so that one disk failing isn't an emergency because, we can still lose a second disk and still have everything stay online, which is, again, one of the reasons why we use RAID Z 2 or RAID Z 3 rather than RAID Z 1. Because with RAID Z 1, if one disk dies, you need to replace it ASAP because if a second disk dies, you've lost all your data. We will preemptively replace disks usually only if they're performing badly. So we've had disks that haven't failed but are, taking a lot longer than, the 10 other identical disks to return data and so on. I think the good rule of thumb is if the disk is out of warranty, you might want to stop using it. At the same time, we have hundreds and hundreds of disks and it gets to be a bit much to keep track of them all. And so oftentimes it is just, if it fails or slows things down or otherwise draws my attention to it, then it can get replaced. So yes, we will sometimes preemptively replace disks, although we don't necessarily have a hard and fast rule about it. We have some 2 terabyte SAS drives that are like 8 years old and is still running happily. Mostly we replaced that machine because it was too small to be useful anymore.
Allan Jude, he is the host of BSD Now. You can find that show at bsdnow.tv and the owner of Scale Engine, the video streaming service that we use here at the Ask Noah Show to bring you the program every single week. Allan, thank you so much for coming on the program. We appreciate you talking to us and sharing your knowledge with ZFS. We'll get you back on the program real soon because there is a lot more stuff to cover. We're just out of time for this episode.
Yep. I'm looking forward to talking to you again sometime.
And that will put another episode of the Ask Noah Show in the books. Throughout the week, we invite you to follow us on Twitter at Ask Noah Show to stay up to date with the latest content, the latest episodes. We also invite you to go over to podcast.asknoahshow.com. That is the show's resource site. It will give you access to all of the articles and references we use to build the show, to include ZFS Mastery, the book by Allan Jude that was referenced today. We'll see you all back here next week at 6 p.m. Central at asknoahshow.com. Have a good week.